the cosine of alpha, the cosine of beta, and the cosine of gamma. Now, we have this property about the cosine of the angle between the two vectors. So we know this from, I'll put it from our corollary. We have cosine theta of two vectors. If we have A and B, A dot B over the magnitude of A times the magnitude of B, when A and B are non-zero vectors. Let me write that. When vector A is not the zero vector, and vector B is not the zero vector. From this, I can find cosine alpha, cosine beta, cosine gamma, because instead of, well, we're talking about the specific direction angle, so cosine of alpha, let's say we have A is back to A1, A2, A3. The direction cosine would be vector A dotted with vector I over the magnitude of A times the magnitude of I. A dotted with I, that is A1, A2, A3, dotted with the vector 1, 0, 0. The magnitude of A is the square root of A sub 1 squared plus A sub 2 squared plus A sub 3 squared. The magnitude of I is 1 squared, a square root of this. So do the sums and do the square root. And in fact, can you tell what that's going to be? A1 times 1 is A1. A2 times 0 is 0. A3 times 0 is 0. The bottom part is just a square root of A1 squared plus A2 squared plus A3 squared. What about this other square root? That's 1. So this is A1 over the magnitude of vector A. It is a unit vector. Okay. All right, so that is cosine of alpha. A1 over the magnitude of A. What about the cosine of beta? I could say similarly, cosine beta is going to be A2 over the magnitude of A. And cosine of gamma, let's see, is that the unit vector? That's a number, isn't it? Okay, A3 over the magnitude of A. So the direction cosines. Okay, what we have left in this